Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to alternating voltage and current related to network theory or circuit theory. So in this video we are going to discuss about the mean or average value of alternating current. Okay, so first a basic review of what we have covered so far. So alternating voltage and current, the alternating quantities, alternating signals are those whose magnitude and direction it continuously changes. Magnitude changes with time and direction reverses periodically after fixed intervals of time. So there are two types, alternating voltage and current. So when an alternating voltage is applied to a circuit, it results in the flow of an alternating current. So they are expressed in this way. The alternating voltage expressed as Vt, which is the instantaneous value, which is equal to Vmax sine omega t. Vmax is the amplitude or maximum value, omega is the angular frequency, t is the time instant. So this is with no initial phase angle. So when initial phase angle is considered, it is plus or minus phi depending upon whether it is leading or lagging. Plus if it is leading, minus if it is lagging. So same goes for alternating current also. In the same way we can express it. Now we have covered the mean and average value in different values of alternating current, where we discussed peak value, peak to peak value, mean or average value, and root mean square value. But what it represents, what is the significance of these parameters? So here mean or average value, what we have covered is it is the average of all the values over a certain period of time. Okay, so for symmetrical waves we only consider half the time period, because the total area under the total time period, it is equal to 0, because positive area which is above the time axis, that is positive, is exactly equal to the area below the time axis. So that's why we use the mid ordinate method. We have discussed it in different values to calculate the mean or average value, where we divide the entire area into equal parts with equal gaps on the time axis, and these equal parts, the middle portion of each part, that is called as the mid ordinate, they have certain values, and depending upon that we calculate the average value or mean value as the sum of mid ordinates over one half cycle and the number of mid ordinates, which is this I1 plus I2 plus I3 plus In by n for average value of current, and V1 plus V2 plus V3 plus Vn by n for average value of voltage. So this, so far this we know about mean or average value. But what exactly it is? So basically when we calculate the mean or average value and also root mean square value, what we are trying to do is we are trying to measure the strength of AC in terms of DC. So what we are trying to do is to find an equivalent DC representation of AC. This is the entire essence of calculating mean or average and root mean square value. So here we are discussing mean, so we'll cover only mean value. So what is mean value of an alternating current? So let us say we have this alternating current with time period t, amplitude I max, like this. So what we are trying to do is we want to find out an equivalent DC representation of this AC current. So what, suppose we have to replace this alternating current, okay, we have this alternating current, we have to replace it with an equivalent DC current. So what will be the accurate DC representation of this AC current? That we are trying to find out in the form of mean current or average current. So the definition of mean value or average value of alternating current is this. The half cycle, because we are determining it for a half cycle, half the time period, from 0 to t by 2, because if we consider the entire cycle time period t, the mean or average value will be 0. So we are only considering one half cycle. Okay, one half cycle here. This is what we are trying to do. So here what it says, the half cycle mean or average value of an alternating current is that value of steady current. Okay, that steady current, which means DC current, which would send the same amount of charge through this circuit. That means this circuit which we have here. Okay, it will send the same amount of charge as is sent by the alternating current for the same circuit for the same time period, that is t by 2. So what we are trying to say is that suppose we pass this alternating current through this circuit for half the time period, it will send the same amount of charge as is sent by this DC current with value I mean. This is called as the average value or mean or average value of alternating current. Mean or average value of the alternating current. So this current, this DC current with value I mean or I average, okay, I average or I mean, it will send the same amount of charge for that duration from here to here, which is t by 2. This will send the same amount of charge as is done by this alternating current for the positive half cycle. Okay, this we are considering only the positive half cycle with duration t by 2. So this portion of this alternating current will send the same amount of charge as is sent by this DC current with value I mean or I average. So we have to determine this value, which is given by Im, this is the I mean or I average value, is given by 2 by pi I max, or which is equal to 0.637 I max, 0.637 times the maximum value of the alternating current. So this is the DC current representation. So we are representing DC in terms of the amplitude, the maximum value of AC. Okay, we are representing DC in terms of the maximum value here, the maximum value of AC. So what it means, this half cycle, this positive half cycle of duration t by 2, it will send the same amount of charge as is done by this DC current Im, which is equal to 2 by pi I max or 0.637 I max for the same duration t by 2 for the same circuit. Now how we got this value, we will find out through mathematical derivation. Okay, so up to this is clear. The mean or average value of an alternating current with amplitude I max is given by 2 by pi I max, which is equal to 0.637 I max. Okay, so this is the thing. Now we'll go for mathematical derivation. So here we'll try to derive the mathematical derivation for the mean value of alternating current. So let us say we have an alternating current okay, so this is omega t, this is the amplitude IT. So it is given by this and this maximum value I max, and here it is minus I max. So it is given by IT is equal to I max sine omega t. Let's reduce the thickness a bit. It's too thick. Okay. Okay, this is the alternating current. IT is equal to I max sine omega t. Angular frequency omega, amplitude I max, time instant t. This is the instantaneous value. Now we are only considering this positive half cycle, not the negative half cycle. The total time period, it is here from 0 to t, and here it is t by 2. Okay, so we are only considering this positive half cycle from 0 to t by 2. Okay, now let this IT, the instantaneous current, it remains constant for a small duration of time dt. Okay, it remains constant for that small duration of time. The small amount of charge dq that will be transferred during this time duration dt, small time duration dt, will be equal to it dt, because we know current is equal to rate of flow of charge. That implies q is equal to it, and small charge dq which is transferred in the small duration dt is equal to it dt, instantaneous current it with multiplied with dt. Now we are considering only the time duration from 0 to t by 2. So the amount of charge, the total amount of charge which is transferred by this instantaneous current it from the positive, from during the positive half cycle, that is from 0 to t by 2, will be, let that be equal to, total charge be equal to q. Okay, which is equal to integration of dq to q, which is equal to, we are integrating with respect to time, so it dt, lower limit 0, upper limit t by 2, the end of the positive half cycle. The positive half cycle is from 0 to t by 2. We are only considering the positive half cycle. So now we can represent this this as okay, we can write this as integration of 0 to t by 2, it is I max sine omega t dt. Okay, so I max is constant, so it will become, I max goes outside, integration 0 to t by 2 sine omega t dt. Okay, so now it becomes I max integration of sine omega t dt, where omega is constant because we are integrating it with respect to time. So this becomes I max by omega minus cos omega t. Integration of sine is minus cos, with t by 2 the upper limit and 0 the lower limit. So this becomes we will also take the minus outside, so it becomes minus I max by omega cos omega t t by 2 0, which is equal to minus Imax by omega cos omega t by 2 minus cos 0. Okay, so this becomes, let me take it to the side, we'll do it side by side. Okay, so that is equal to minus Imax by omega. Here we know that omega, let me use a different ink here, omega is equal to 2 pi f, where f is the frequency in hertz, or 2 pi by t, where t is the time period, because frequency and time period, they are reciprocals, the inverse of each other. So here we can write omega as 2 pi by t. So we'll write it as cos, sorry, white ink. So it is equal to cos, omega will write it as 2 pi by t multiplied with t by 2 minus cos 0 degree. So here t gets cancelled, this 2 it gets cancelled, so this becomes minus Imax by omega cos pi minus cos 0 degree, which is equal to minus Imax by omega minus 1, cos pi is minus 1, cos 0 degree minus 1. So this is only 0, okay, no degree, because we are considering radian. So by mistake I have written here 0 degree, so this is only okay. So this is equal to how much? This is equal to minus Imax by omega into minus 2, which is equal to 2 Imax by omega. So what is 2 Imax by omega? It is the total charge transferred by the alternating current, total charge transferred by the alternating current in the positive half cycle, that is 0 to t by 2, this. Now we want to determine the equivalent DC representation. Okay, so 2 Imax by omega here, 2 Imax by omega here is the charge sent by the positive half cycle from 0 to t by 2, okay, Imax. This is AC. We want an equivalent DC representation. We want an equivalent DC representation. We want an equivalent value, this value, which we'll call as I mean or I average, which will send the same amount of charge in the same time period. Okay, so let that current be I mean. Okay, let that current be I mean. Okay, so if I mean is the mean value of alternating current, then by definition it will also transfer the same amount of charge in time period t by 2. So I mean into T by 2 will be also be equal to Q. This and this will be equal. Okay, this is by AC, this is by DC, the mean value, this. Okay, it should be equal. I mean into T by 2 should be equal to 2I max by omega. This is for AC, the positive half cycle, the positive half cycle of AC. This is by this equivalent DC current, which we are calling the mean or average value. That is the essence of mean or average value, isn't it? DC representation of AC, equivalent DC representation of AC. We are trying to find out an equivalent DC representation or DC value of this positive half cycle of alternating current. So that is I mean, let that be I mean. Now by definition, it will send the same amount of charge in time period T by 2 as is done by this positive half cycle of alternating current, which we have calculated here as 2I max by omega. So I mean into T by 2, it should also be equal to Q, which is equal to 2I max by omega. It is equal to 2I max by omega. That implies I mean into T by 2 is equal to 2I max by omega is how much? 2 pi by T. So this by T, it will go to the numerator, so it will become, that implies I mean into T by 2, it is equal to 2I max T by 2 pi. So on both sides T will get cancelled, here 2 will get cancelled, so that implies I mean is equal to 2 by pi I max, which is also equal to 0.637 I max. 2 by pi is equal to 0.637 I max, which was the value which we derived. Okay, we directly got that value. I showed you that value. Here we have mathematically derived it, that the equivalent DC value, that is the mean value or average value, which is the equivalent DC value, that is equal to 2 by pi times the maximum value. Okay, 2 by pi times the maximum value of the alternating current. This is the equivalent DC representation. So the equivalent DC current is equal to this DC current is equal to 2 by pi I max. This. So this value, when this value of current, when it is passed for T by 2, half the time period, it will send the same amount of charge as is sent by this positive half cycle of the alternating current. This and this, they are the same, equivalent representation. That is the essence of calculation of mean value or average value of alternating current. And here we are only using one half cycle, because if we consider the entire cycle, positive and negative, it will cancel out each other, because positive half cycle is the same as the negative half cycle in magnitude, but it is in opposite direction, so it will cancel out each other, because it is a symmetrical waveform. Sinusoidal waveform, it is a symmetrical waveform. So this here we have calculated the value, we have mathematically derived it. Okay, so this is the thing here.